this session, we shall go through some more special and important problems in differential equations. Let us look at the problem available on the board. dy by dx is equal to xy plus 2x plus 3y plus 6. Then y of 0, how much? Okay, let us try to get it simplified. This is equal to, from these two, I can get x as a common factor. From these two, I can get 3 as a common factor. Again, this can be written as y plus 2 into x plus 3. Y plus 2 into x plus 3. Therefore, dy by y plus 2 is equal to x plus 3 dx. X plus 3 dx. Isn't it? Therefore, it is directly available in variable separable model. Am I correct? Yes, of course. dy by y plus 2 is equal to x plus 3 dx. Okay. Integrating on both the sides, log mod y plus 2 is equal to x square by 2 plus 3x plus c. Implies y plus 2 is equal to e power x square by 2 plus 3x plus c. Okay, therefore y is equal to minus 2 plus e power x square by 2 plus 3x plus c. And we want to have y of 0, isn't it? Therefore, y at 0 is minus 2 plus e power c. Isn't it? You take x as 0. E power 0 plus c is nothing but c. C is an arbitrary constant. Actually speaking, he must give one more information to find c itself in the beginning. But he has not given any such matter. That is why we leave the answer like that only, minus 2 plus e power c, where c is some fixed constant, integral constant of integration. That is to be decided with another information which has not been given here. We cannot help for that. Therefore, the answer is, that is, y at 0 is minus 2 plus e power c is the correct answer. The next question before us is dy by dx is equal to cos of x plus y. Then what? Also, it has been given that y at pi by 2 is 0. That is, the value of y when x is pi by 2 is 0 is given. I think you can understand the reason for this data. Unless such things are given, we will not be in a position to have the value of the constant c of integration. Justly to know, absolutely to know the value of c only, it has been given. Okay, let us try. As this is of another fashion in variable separable method. Look, in this method, I like to take x plus y is equal to t. Then 1 plus dy by dx is equal to dt by dx. Suppose you add 1 on both the sides. What happens? dy by dx is equal to 1 plus cos t. Am I correct? I believe that 1 is added on both the sides. It becomes 1 plus dy by dx. But 1 plus dy by dx is just nothing but dt by dx. And we have added 1 plus cos t. Isn't it? Okay. This 1 plus dy by dx becomes dt by dx. dt by dx is equal to 1 plus cos t. Now it is directly in the model of variables separable pattern. Come on, bring that 1 plus cos t here. dt by 1 plus cos t is equal to dx. What is 1 plus cos t? 2 cos square t by 2, isn't it? That is dt by 2 cos square t by 2 is equal to dx. Okay, let us integrate it on both the sides. Integral of half into secant square t by 2 dt is equal to integral of dx. Am I correct? What is half secant square t by 2 dt? For secant square t by 2, it is tan t by 2. By half, it's just nothing but tan t by 2. Tan t by 2 is equal to x plus c. Tan t by 2 is equal to x plus c. Now let us replace the original value of t. What is t? Where did you put it? X plus y is equal to t. Hence the actual answer is tan of x plus y by 2 is equal to x plus c. X plus c. From this, x plus y by 2 is equal to tan inverse of x plus c. Tan inverse of x plus c. Okay, therefore, let us use y at pi by 2 is 0, isn't it? Okay, we can use here itself. Okay, x plus y by 2 is equal to tan inverse of x plus c. Well, so x plus y is equal to 2 tan inverse x plus c, or y is equal to 2 tan inverse x plus c minus x. This is the solution y, the general solution. And in this general solution, the constant c is to be obtained, isn't it? Y at pi by 2 is 0. That is, if you put x is equal to pi by 2 plus pi by 2 is pi by 4 plus y by 2 is equal to pi by 2 plus c. From that you are supposed to get c. And for this matter, we need some space. You please follow steps carefully. Well, now it is our duty to know c and y of 0, isn't it? Well, for that purpose, you introduce the constant on the left hand side instead of right hand side. It becomes an easier process. Therefore, x is equal to tan t by 2 plus c, or x is equal to tan of x plus y by 2 plus c. Now, but y at pi by 2 is 0. So it passes to the point pi by 2 and 0. What happens to that? Pi by 2 is equal to tan of pi by 2 plus 0 by 2 plus c. Pi by 2 plus by 2 is pi by 4. Tan pi by 4 is 1. 1 plus c is equal to pi by 2. Therefore, c is equal to pi by 2 minus 1. Isn't it? Pi by 2. By 2 is pi by 4. Tan pi by 4 is 1. C plus 1 is equal to pi by 2. Hence, c is pi by 2 minus 1. Pi by 2 minus 1. Okay. The next part. Hence, the reframed solution becomes x is equal to tan of x plus y by 2 plus pi by 2 minus 1. Now, what is the actual question? We are supposed to have y at 0. Therefore, y at 0 is 0 is equal to tan of 0 plus y by 2 plus pi by 2 minus 1. Therefore, tan y by 2 is equal to 1 minus pi by 2. Tan y by 2 is equal to 1 minus pi by 2. Hence, y by 2 is equal to tan inverse of 1 minus pi by 2. Or y is equal to 2 tan inverse 1 minus pi by 2. This gives you the required answer. The next question is on the board. What is he asking you? You please observe. There has been a differential equation. The solution of this equation represents system of straight lines, system of circles, system of parabolas, system of ellipses. These are the options given. So, what is to be done here? You solve the equation with your usual style. After solving it, observe the nature of the solution. What shape that it resemblances, what shape that it represents, that you may have to notice. Come on. This can be written as y dy is equal to root of x square plus y square dx minus x dx. Am I correct? Implies y dy plus x dx is equal to root of x square plus y square dx. Okay, implies y dy plus x dx by root of x square plus y square is equal to dx, correct? Y dy plus x dx by root of x square plus y square. Actually, we have not listed, we have not thrown this form in the list of general differentials. You can easily observe this. This is nothing but d of root of x square plus y square. Okay, I think of that separately, d of root of x square plus y square. What is that differential? D of root x means 1 by 2 root x square plus y square into, for x square it is 2x dx and plus y square it is 2y dy. 2 will be cancelled, of course. What is going to be remained? X dx plus y dy by root of x square plus y square. That is, you must be able to catch it. You must be able to recollect this on the spot itself. By looking at this, we must be able to recollect that this is just nothing but the differential of d of root of x square plus y square is equal to dx. If you could recollect this, this becomes so easier. This becomes so easier. Otherwise, there has been a big process, of course. Dy by dx is equal to root of x square plus y square minus x whole divided by y, and converting that into a homogeneous form, which is the next form we are going to tackle with that, and take y is equal to vx. There has been a lengthier process. We are not supposed to do that here because justly because y dy plus or x dx plus y dy by root of x square plus y square is just nothing but d of root of x square plus y square. There is a differential of root of x square plus y square is dx. Well done. Let us now try to integrate it on both the sides so that you have a root of x square plus y square is equal to x plus c. X plus c. Therefore, x square plus y square is equal to x plus c whole square, right? Implies x square plus y square is equal to x square plus 2cx plus c square. You can cancel one x square. What are you going to have? Y square is equal to 2cx plus c square, right? Anybody can easily trace the shape of the curve whose equation is y square is equal to 2cx plus c square. Surely it represents a parabola and c is the constant here, so it forms a system of parabolas. So what is the right option to be chosen? The solution of this differential equation represents a system of parabolas. That is the right answer. And if you want to have the general solution, the general solution is y square is equal to cx plus c square. That's it. That is the answer. The next question is ready on the board. You please observe this. dy by dx is equal to x minus y by x plus y, and y of 1 is equal to 1. What does this mean? If you put x is equal to 1, the value of y is 1. And what is required here? Y of 0. It does mean y at x equal to 0 whole square is required. Okay, actually speaking, this looks like a homogeneous function. And you need not proceed in that way of that homogeneous model. But we can do like this. Cross multiply x plus y dy is equal to x minus y dx. X dy plus y dy is equal to x dx minus y dx. You bring all the things to one side, we have y dy plus x dy plus y dx minus x dx is equal to 0, correct? Y dy, x dy plus y dx minus x dx is equal to 0, implies y dy plus d of xy minus x dx is equal to 0, correct? You observe this format. We could have already noted this standard shape. It is d of xy. You can remember, you can recollect. Okay, integrate on both the sides. What is the integral of y? Y square by 2 plus xy minus x square by 2 is equal to you have to take a constant on the right hand side, and I like to take the constant as c by 2 instead of c. Why? Because at so many places in the left hand side we are observing by 2. Justly for the sake of simplification, just for the sake of simplification, I've taken c by 2 instead of c. Now you multiply it with 2, what happens? The solution is now y square plus 2xy minus x square is equal to c. Am I right? Is equal to c. Now let us use this information to get c. But y of 1 is equal to 1, isn't it? Implies 1 square plus 2 into 1 minus 1 square is equal to c. Automatically 1 square, there is 1 and 1 get cancelled, leaving you c is equal to 2. C is equal to 2. Okay, c is equal to 2. What is the question actually? Y of 0 whole square. Y at 0 is, come on, what is y? Y square plus 2 into 0 into y minus 0 square is equal to c. Isn't it? I have taken just x equal to 0. Well, therefore this is 0, this is 0. Y square is equal to c. Y square is equal to 2. Y is equal to root. Y is equal to root 2. Or rather plus or minus 2. But actually y square we want, not y. Y of 0 whole square, isn't it? Therefore, y of 0 whole square is 2. So what is the correct answer? 2 is the right answer. Well, my dear, this type of transforming the required things and clubbing them suitably so as to recollect a famous differential, or later on we call it integrating factor. Yes, of course, is it's very, very essential here. So this is a key step here. Like that we have the answer. So what is the required answer? It is 2. The next question. Now it is our turn to look at the next question which is available on the board. Dy by dx is equal to 2x minus y plus 1 by x plus 2y plus 1, and y of 1 is equal to 1, then y of 0 is. That is the question. Well, my dear, this looks like a non-homogeneous equation which can be convertible to homogeneous form. Of course, those methods we have not yet commenced, we have not yet dealt with. But you see, by just cross multiplying and rearranging the terms suitably by choosing a suitable differential or so-called integrating factor, it can be done. Now, the thing is, in which problems should you think of the case in that way, or in which problems you may have to use that non-homogeneous form pattern? That is the very important to notice. Look here, the coefficient of y, or if you call it a1x plus b1y plus c1 a2x plus b2y plus c2, then b1 is equal to minus a2. You look here, b1 is minus 1, a2 is 1, isn't it? In such a case, we just cross multiply. Okay, what is going to happen? Let us do cross multiply. X plus 2y plus 1 of dy is equal to 2x minus y plus 1 of dx. Bring that here. X plus 2y plus 1 of dy plus y minus 2x minus 1 of dx is equal to 0. Correct? Is it right? Now you multiply x dy plus 2y dy plus dy plus y dx minus 2x dx minus dx is equal to 0. Correct? Now you club these two, x dy plus y dx, x dy plus y dx, annexed 2y dy minus 2x dx plus dy minus dx is equal to 0. What is the benefit of clubbing these two and putting them in a bracket? We can easily recollect what is x dy plus y dx. Even in the previous problem also we could have made use of that. What is x dy plus y dx or y dx plus x dy? It is just nothing but d of xy, right? Implies d of xy plus d of y square minus d of x square plus dy minus dx is equal to 0. And as the next step, which is the straight answer on integrating, what are you going to have? Xy plus y square minus x square plus y minus x is equal to c. Well, my dear, here there are two pieces of responsibility is laid on our shoulders. What is that? Number one, you have to use y of 1 is equal to 1, and of course by making use of this you will be able to have c, and using the value of that c we get y at 0, isn't it? We get y at 0. We shall look at that. You please notice these steps. I like to remove them. This is of course the general solution we could have obtained. Now we are to use y at 1 is 1. Making use of that, we find y at 0. Let us try. But y at 1 is 1. What is the meaning of that? The curve passes through 1, 1, isn't it? The curve passes through the point 1, 1. Make use of it. 1 into 1 plus 1 square minus 1 square plus 1 minus 1 is c. 1, 1, 1, 1. Therefore, c is equal to 1. C is equal to 1. Therefore, xy plus y square minus x square plus y minus x is equal to 1 is the solution. Okay then, what is the actual question? What is the requirement? What do you require actually? Y at 0 we want to have. Therefore, y at 0 is 0 into y plus y square minus 0 square plus y minus 0 is equal to 1. Therefore, y square plus y minus 1 is equal to 0. Isn't it? Therefore, y is therefore equal to minus b plus or minus root of b square minus 4 is c is 1 plus 4 is 5 by 2. That is the answer. And we are not given information about y, whether it is positive or negative or any other thing. Therefore, there itself we put a full stop. That is the answer. That is y at 0 is minus 1 plus r minus root 5 by 2. Notice that. The next question is, of course, the question looks so lengthier, but the solution is very simple. You can observe that. You can follow. First of all, let us see the nature of the question. 2 into x minus y dy by dx into x square plus y square is equal to x square minus y square into y minus x dy by dx. It has also been given that y of 1 is 0. What does it mean? Y at 1. That is, if you substitute x is equal to 1, then the answer for y will be 0. And in short tips to say, the curve passes through 1, 0. The curve passes through 1, 0. And you are supposed to have the general solution. Of course, by making use of this, you will be able to know the constant c of integration while it has been obtained by integrating to get the solution. Isn't it? Okay, let us try. This is equivalent to 2 into x dx minus y dy into x square plus y square is equal to x square minus y square into y dx minus x dy. Isn't it? Isn't it? I've taken the LCM and simplified by, of course, multiplying with the differential dx. And it is again, this is 2x dx minus 2y dy by x square minus y square is equal to y dx minus x dy by x square plus y square. Am I correct? How simple it has become, you can see that. As of course, you try to guess this. This is just nothing but d of log of x square minus y square. Of course, log mod. Do you have any doubt? You clarify it, use for yourself. What is d of log of x square minus y square? What is that? Log of, so 1 by x square minus y square. For x square it is 2x dx and for y square it is 2y dy, isn't it? It is straight and simple as such. So it is d of log of x square minus y square. And you observe the right hand side. It is one of the famous differentials. It is the just nothing but g of tan inverse x by y or y by x. Come on. How to recollect? How to point it out? Y dx is started here, isn't it? So it is d of x by y. Why? Because while using u by v formula, u dash comes in the beginning, isn't it? Therefore, log of x square minus y square is equal to tan inverse of x by y plus c is the answer. Stop there. Well, he has given one more information. What is that? Y at 1 is 0, isn't it? Okay, that is, if you put x, it passes through 1 comma 0. It passes through 1 comma 0. The utility of that information is just to know c. Observe the solution carefully. Still, there has been a beautiful responsibility on your shoulders to know c, yes, to find c. We shall do that. Observe it carefully. I would like to remove the steps and some space will be saved, of course, to get c. Well, my dear, this is the key step. This is the key step which yields this step. Of course, by remembering the famous differentials, rather famous integrating factors is valuable. By remembering them only, we are able to do this. To recollect them is very, very important here. As you look at this, this is d of log of x square minus y square, and that is d of tan inverse x by y. the actual work is simplified, isn't it? Immediately in the next step itself, we will be able to get the answer. Of course, still C is to be found. We shall do it. That is the general solution we could have obtained. But y at 1 is 0. That is, let us name this solution as 1. 1 passes through 1, 0. Substitute that. Log of 1 square minus 0 square is equal to tan inverse of 1 by 0 or infinity. This is 0. Tan inverse infinity, you can recollect it to be pi by 2. Hence C is equal to minus pi by 2. C is equal to minus pi by 2. Therefore, 1 becomes log mod x square minus y square is equal to tan inverse x by y minus pi by 2. That gives the answer. That gives the answer. The next question is ready on the board. X dy minus y dx plus x cos ln x is nothing but log x to the base g is 0. And it is y of 1 is 1. That is, the curve passes through 1, 1. The curve passes through 1, 1. And what is the value of y when x is e? That's the question. It is one of the simplest questions. Yes. How? Implies x dy minus y dx by x square plus x cos ln x by x square is equal to 0, isn't it? I think you could have observed what I could have done. What is that? I have divided on both sides by x square. What happens? X dy minus y dx by x square is of course one of the famous differentials. It is just nothing but d of y by x. Am I right? Yes, of course, d of y by x. And now here x can be cancelled. Cos log x by x. You imagine in indefinite integrals model, if you take log x is equal to t, 1 by x dx is dt, it is cos t dt, integral is sin t, that is sin log x, isn't it? Therefore, this is just nothing but d of sin ln x is equal to 0. D of sin ln x is 0. Now, by integrating directly, you will be having y by x plus sin log x to the base e is equal to constant. Is equal to constant. One more thing he has given us. What is that? It passes through 1, 1, isn't it? But this is of course the solution. Okay. In this solution, C is not known. We are to get C. How can we get? Of course, by making use of this information. What is that? Y of 1 is equal to 1. But y at 1 is 1. So it passes through 1, 1. What do you say? 1 by 1. Log 1 is 0. Sin 0 is 0 is equal to C. Implies C is equal to 1. What is C? 1. Therefore, use C is equal to 1 in the general solution. Let me name this equation 1. Therefore, 1 becomes, how does it become? Y by x plus sin ln x is equal to 1. Is equal to 1. Well, let us now approach the question. What is required actually? We are required to have y of e, that is y at e, that is the value of y where x is e. If x is equal to e, then y by e plus sin ln e is equal to 1. What is ln e? Log x, log e to the base e. What is log e to the base e? 1. Isn't it? Log e to the base e is 1. Therefore, y by e plus sine log x to the base v, log e to the base v is 1, sine 1 is equal to 1. Therefore, y by e is equal to 1 minus sine 1, or y is equal to e into 1 minus sine 1. That is y at e. Beautiful problem. It's very simple, of course, but two more steps are needed. What are they? To find c and to use c to get y at e. That's all. Of course, in this solution, this part is the key step. This part contains the key step. You have to recollect that d of y by x is nothing but this, and d of sine log x is nothing but that. That is the matter. Follow it. Let us go through some more special problems in differential equations. You look at the question on the board. X cos y by x into x dy plus y dx is equal to y sin y by x into x dy minus y dx. What is the solution? A clear problem with no additional burdens. No question of any other information given. We are not supposed to find any new item, a y at 0, y at 1 like that. It has not been asked at all. We are just supposed to have the general solution only. Let us try to get it. Look here. X dy plus y dx by y is equal to sin y by x by cos y by x into x dy minus y dx by x. I think you could have understood this transposition. This cos y by x has been sent to that side, that y has brought this side, this x has brought that side, sent to that side. Now you imagine it is x dy plus y dx. Is it in the standard form of differentials, or anything is to be made here? Similarly, that is also x dy minus y dx is there. Here you need x square. Here you need x square. If at all x square is present, then you can treat this as d of y by x, isn't it? Okay. Therefore, I am dividing the entire equation by x. Then x dy plus y dx by xy is equal to tan y by x into x dy minus y dx by x square, isn't it? Now, you imagine x dy plus y dx by xy. This is nothing but the differential of log xy. Am I correct? Log xy is equal to tan y by x into, it is nothing but d of y by x, isn't it? D of y by x. Okay. Integrate it on both sides. D of log xy is equal to integral of tan y by x d of y by x. What will be the answer? Here it is log xy, and there it is, you take y by x as t in your mind. It looks like tan t dt, isn't it? Integral of tan t dt, what is that? Log mod secant t, that is log mod secant y by x plus c. Plus c. You see, here it is logarithm, here it is logarithm. Therefore, by observing the nature of these terms, expressions in the answer, we can change the constant as some log c. As log c. What will be the next shape of that answer? Therefore, log xy is equal to, come on friend, log m plus log n, log mn. Therefore, it is log of c into secant y by x. So that if you can omit logarithmic signs on both the sides, xy is equal to c secant y by x. That will be the general solution. That is the final answer. As we need to have just the general solution only. We stop there itself. My dear friend, this idea is very important here of transforming the given terms or rearranging the given terms so as to get a standard differentials. It will be very suggestible and very important here to have this step. This is the key step here, you understand. Look here, this is here also the general solution is just required. No question of any other finding of any other value at x equal to something or something like that. It has not been given at all. We are just supposed to have the general solution from this. Look here, x dx plus y dx, y dy minus x dy is equal to 0. From this, x dx plus y dy is equal to x dy minus y dx. Minus y dx. This is of course d of xy, no problem. But what do you say about that? X dy minus y dx. Simply x dy minus y dx does not serve the purpose. Some denominator must be there. Either by xy, by x square, by y square, by x square y square, or x square plus y square. Something like that there must be present. Then only it can be brought into the standard forms of differentials. You think of which is beneficial. You keep one particular thing in your mind. If you place something in the denominator, the same thing appears here also. If you get a benefit there, you should not get a harm here. Come on, think of. Yes. Now, x dx plus y dy, I am dividing on both the sides by x square plus y square. By x square plus y square. Come on. This is nothing but, of course, you multiply with 2 also. 2x dx plus 2y dy by x square plus y square is equal to 2 into x dy minus y dx by x square plus y square. Come on friend, LHS is just nothing but d of log of x square plus y square. You can easily believe it, you can easily trace it. Come on. What is the differential of log of x square plus y square? For the logarithmic function, 1 by x square plus y square, and again 2x dx plus 2y dy, isn't it? It's very simple to trace it. And what you say about the RHS? It is just nothing but d of tan inverse, come on, x by y or y by x. In the first step we have dy, not dx. So it is y by x. Tan inverse of y by x. Now you integrate it on both the sides. You will be having, come on, log mod x square plus y square is equal to 2 tan inverse y by x plus c. As x square plus y square is positive, there is no harm at all even if you omit that modulus symbol. You can say log of x square plus y square is equal to 2 tan inverse y by x plus c is the general solution. Is the general solution. Nothing more than that. He has just asked us to have the general solution only. Therefore, there ends the matter for that problem. Understand it and follow them carefully. Consider the problem. Y dx minus x dy plus log x dx is equal to 0 is given. Moreover, y of 1 is minus 1. What does it mean? When x is 1, y is minus 1. That is, a point on the curve is 1 comma minus 1. And we are asked to have y at E. That is, it passes through the point E comma, what is the y coordinate? That is required. It is also another example of a simple problem. Justly to have a good practice of all the differentials, we have been considering such problems. This is y dx minus x dy is here. Here it is log x. So for such things, there must be a denominator, either x square or y square or xy or x square plus y square, something like that. You choose the proper expression which does not make any harm to this. Which does not make any harm to this. Yes. Well, I like to have x square in the denominator. Why? Like here, this is log x dx is therefore is equal to x dy minus y dx. And you divide by x square on both the sides. So that we have the RHS is d of y by x. D of y by x. And it is log x by x square. Now, let us now try to get it integrated. How to get it? Implies y by x is equal to integral of log x into 1 by x square dx. Log x into 1 by x square dx. Of course, you may have to use integration by parts. Let us use it. This is equal to f of x into integral of this g of x minus integral of 1 by x square is minus 1 by x. I think you could have recollected it. You could have remembered it. Integral of 1 by x square is minus 1 by x minus f dash x, that is 1 by x into 1 by x square. Integral of 1 by x square is minus 1 by x dx. Okay, the next one. The next step. Therefore, y by x is equal to minus 1 by x into log x minus of minus plus 1 by x into 1 by x, 1 by x square. Integral of 1 by x square is again minus 1 by x, minus 1 by x plus c. Plus c. Okay, let me multiply throughout by x. What is going to happen? Y is equal to minus log x minus 1 plus cx. That is y plus log x plus 1 is equal to cx. That is the ultimate solution. Of course, it has been given that y of 1 is minus 1, isn't it? But y of 1 is minus 1. Therefore, minus 1 plus log 1 plus 1 is equal to c into 1, c. Log 1 is 0. 1 and minus 1 go away. As a result, c is equal to 0. C is equal to 0. Ultimately, what is the solution? Y plus log x plus 1 is equal to 0 is the kernel. Is it the answer? No. No. We are supposed to have y at e. That is, what happens when x is e? If you put x is equal to e, what is log e? Log e to the base is 1. 1 plus 1 is 2. So y plus 2 is equal to 0. And hence y is minus 2. Y is minus 2. I think you could have understood that. Or otherwise, you observe. Shall I remove these steps? At the last step, we could have had the solution as y plus log x plus 1 is equal to 0. And we want to have y at e. Therefore, at x is equal to e, what is going to happen? We want to see y plus log e plus 1 is equal to 0. What is log e? 1. 1 plus 1, 2. So y is equal to minus 2. So what is ultimately the answer is minus 2. The first piece of information, y of 1 is equal to minus 1, helped us to find c. Of course, c is 0, and hence the solution has become y plus log x plus 1 is equal to 0. Well done. Making use of that c, we could have got the solution like this. But the actual question is y at e is required. Okay, let us substitute x is equal to e in that solution. What is going to happen? Come on, y plus log e plus 1 is equal to 0. 1 plus 1 is 2. If it goes this side, y is equal to minus 2, where x is equal to e. That is, y at e is minus 2 is the final and ultimate answer. Look at the next question. It's available on the board. Y dx plus y square dy is equal to x dy. X dy. Many pieces of information have been given. X is a real number, y is a positive real number, y of 1 is 1. Y of 1 is 1 means the curve passes through the point 1, 1. And what is y of minus 3? What is y at minus 3? That is, what is the value of y when you substitute x is equal to minus 3? That is the question. That is the requirement. Well, let us try to solve it first of all. Come on. This can be written as y dx minus x dy plus y square dy is equal to 0. And then let me divide throughout by y square, so that y dx minus x dy by y square plus dy is equal to 0. Oh, how happy it is, how simple and direct it is. Look here, this is nothing but d of x by y, isn't it? Hence, this is d of x by y plus dy is equal to 0. Let us integrate it on both the sides with respect to e. Then what happens? This is x by y plus y is equal to c. Now, the first piece of responsibility is to find c. How to get c? He has given us a piece of information here. It passes through 1, 1, isn't it? This is the solution actually. But y at 1 is 1. What do you mean by that? 1 by 1 plus 1 is equal to c. Therefore, c is equal to 2. C is equal to 1 plus 1 is 2. Implies the general solution is x by y plus y is equal to 2. And we are asked to have y at minus 3. What happens to that? If x is equal to minus 3, then minus 3 by y plus y is equal to 2. Implies minus 3 plus y square is equal to 2y. Implies y square minus 2y minus 3 is equal to 0. Implies y minus 3 into y plus 1 is equal to 0. Isn't it? These are the two linear factors that can be brought. From this, we have y is equal to 3 or y is equal to minus 1. Well, my dear, at this instance, we have to remember that y is given to be positive, isn't it? So it cannot be minus 1. It cannot be minus 1. Therefore, y is not equal to minus 1 since y is greater than 0. Implies y is equal to 3 when x is equal to minus 3. Therefore, the right answer is y at minus 3 is 3. Y at minus 3 is 3. Please observe the steps. If dy by dx is equal to tan square of x plus y, Then sine of 2x plus 2y is equal to how much? Another variety of problem. Yes, as it looks, it is not directly thrown into the model of variable separable pattern. Something must be done. What is that? That must be done is put x plus y is equal to t. Then 1 plus dy by dx is equal to dt by dx. That can easily be understood, of course, by differentiating with respect to x on both sides. Well done. Suppose 1 is added. You imagine in your mind, just to reduce the number of steps. 1 plus dy by dx is then equal to dt by dx. 1 plus tan square t is nothing but secant square t. Secant square t implies dt by secant square t is equal to dx. Implies dx is equal to cos square t dt. Cos square t dt implies integral of dx is equal to integral of 1 plus cos 2t by 2d. I could have written cos square t as 1 plus cos 2t by 2. Implies x is equal to half into t plus sin 2t by 2 plus c. Implies 2x is equal to t plus sin t cos t. Am I right? Sin t cos t. Let us think of the question. What is the requirement? Sine of 2x plus 2y, isn't it? Sine of 2x plus 2y is required. What is mean by sine of 2x plus 2y? Is it not sine 2t? Of course, it is sine 2t. Sine 2t by 2. Let it be like that. Let it be like that. Is equal to half into 2t plus sine 2t by 2. By 2. See, by looking at all these things, let me take the constant to be some c by 4 in the beginning itself. This is x is equal to. Now you multiply with the 4. What happens? 4x is equal to 2t plus sine 2t plus c. So 4x is equal to, what is 2t? 2x plus 2y plus sine 2t plus c. Here it is 4x, it is 2x, isn't it? You bring 2x plus 2y this side, what happens is 2x minus 2y minus c is equal to sine 2t. By the by, what is sine 2t? It's just nothing but sine of 2x plus 2y. Therefore, at last, the required answer, that is sine of 2x plus 2y, is equal to 2 into x minus y minus c is the right answer. That's all. So, in the process of obtaining the integral, or rather the solution, you must see that you will be able to have sine of 2x plus 2y directly. This is the speciality in this problem. Okay, and this is the key step here to follow. Let me try to explain you once again. You take x plus y is t. So 1 plus dy by dx is dt by dx. If you add 1 on both the sides, 1 plus dv by dx becomes dt by dx. And 1 plus tan square t is nothing but secant square t. You bring that secant square t that side, this side, and dx that side. So that dx is equal to cos square t dt. And we know that cos square t is 1 plus cos 2t by 2. And by using the general, most standard, very easy integration pattern from indefinite integrals, we will be able to have the answer. That is the question. Look at the question. If x plus y whole square into dy by dx is equal to a square, y is equal to 0 when x is equal to 0, this is all the given information, then he is asking, by substituting what value for x by a you will be going to get y is equal to a. So he has given the value of y and we are supposed to have the value of x by a which yields y is equal to a. Okay, for all these things it is necessary to have the general solution first of all. Look here, as usual, put x plus y is equal to t. Automatically 1 plus dy by dx is equal to dt by dx implies dy by dx means dt by dx minus 1, right? And in the place of dy by dx we will be going to write dt by dx minus 1. Therefore t square into dt by dx minus 1 is equal to a square. Therefore t square into dt by dx minus t square is equal to a square, right? Well done. Therefore t square dt by dx is equal to a square plus t square. A square plus t square. Therefore t square by a square plus t square dt is equal to dx. Is equal to dx. Therefore t square plus a square minus a square by a square plus t square dt is equal to dx. Implies t square plus a square by t square plus a square is 1 minus a square by a square plus t square dt is equal to integral of dx. Just a minute. It is dt but not dx. Integral of 1 is dt is t minus a square into 1 by a tan inverse t by a is equal to x plus c. Okay, what is t? X plus y minus a into tan inverse x plus y by a is equal to x plus c. We can cancel one x. Okay, what will be the next step? From here itself, you make use of this. When y is 0, when x is 0, y is 0. It passes through origin, isn't it? But y of 0 is equal to 0. So it passes through origin. Come on, substitute. 0 minus a into tan inverse 0 is equal to c, therefore c is equal to 0. C is equal to 0. 0. 0 plus 0, 0. 0 by a 0. Tan inverse 0 is 0. 0 into a is 0. 0. C is equal to 0. Okay. Therefore, the ultimate solution is y is equal to a tan inverse x plus y by a. X plus y by a. Okay, up to that much we have got the solution, and we are required to have when does y become a? When does y become a? We shall see. Let us see. Therefore, it is y by a is equal to tan inverse of x by a plus y by a. We like to have y is equal to a, isn't it? We like to have y is equal to a. Therefore, if y is equal to a, Then a by I is 1. 1 is equal to tan inverse of x by a plus 1. You can see, we can very easily look at, therefore x by a plus 1 is tan inverse of x by a plus 1 is 1. Therefore x by a plus 1 is tan 1. Is tan 1. Hence what is x by a? Tan 1 minus 1. That is required because we require to have x by a only, isn't it? So the required answer is tan 1 minus 1. That's beautiful.